Today we're going to talk a little bit about circles and some special stuff that goes along with circles. If you would join me in your notes packet on page number 10, that's where you're going to find this lesson for today. So join me on page 10. We're going to start off with a couple words to talk about circles. First of all, every circle is going to have what we call a center, and while that's not a word listed here, that center is important to us. If you draw a line from the center to the outside of the triangle, we call that a radius. And when we see that in our formulas, we're going to see it as a lowercase r for radius. If you have length going all the way across your circle passing through the center, in other words, you have two radii put together, they're just going from one end to the other, we call this a diameter. And we'll see that as a lowercase d in our formulas that we work with. When we just have a line that goes across our circle but does not specifically pass through the center, we call this a chord. And then going all the way around the exterior of the circle, we call that the circumference. C-I-R-C-U-M-F-E-R-E-N-C-E. Circumference. Circumference goes all the way around. Similar to the way that we've seen a capital A for area, we will see circumference as a capital C. Okay? So key concept here for you, how are the radius and the diameter related to each other? When we talked about diameter here, we said the diameter is equal to two radii put together. So the diameter is equal to 2 times the length of the radius. Or if you want to put that the other way, if you were actually to get radius by itself, to find the radius, you would do the diameter divided by 2 because you only need half of it for this. One of the things that we're going to see when we look at the formula for area of a circle, we're going to see area equals pi r squared. And we're going to start off talking about a circle's area today. We see this pi symbol, and pi is actually what we call an irrational number. And if you know anything about pi, you know that there is Pi Day, which is 3/14, coming up in a little bit here, March 14th. An irrational number is actually a decimal that continues on forever and ever and ever, but it never repeats itself and it never stops. So pi is one of those numbers that starts off 3.14, blah, 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 and keeps on going. And yes, there are Pi Day competitions for you to memorize digits of pi. So when we use pi for our purposes, we're going to just use 3.14. So we're going to actually replace our pi symbols with 3.14 in our problems. So on this same page, we have our circle. And taking a look at this one, notice that this line only goes from the center to the outside. So this is just a radius right here. We write our formula for area of a circle. Area equals pi r squared. Remember, that's line 1. Line 2, we actually go ahead and plug in. So we're going to leave pi here just for a minute. Pi times 5 is our radius squared. And we're going to actually put an extra line with this one, or kind of like a double line sort of thing. Pi, we can kind of consider it almost like an x, almost like a variable, and you'll see answers for this written out. 5 squared is 25. You'll see the answers written out as 25 pi. That is one way of writing the answer. The other thing that you can do is to go ahead and draw a squiggly equal sign here, and you can actually grab your calculator and do 25 times 3.14, and that's going to give you 78.5. The reason we put the squiggly equal sign here is because we are approximating, we're estimating here kind of in a way, because we chopped off pi at 3.14. So we end up with 78.5, and my units were centimeters, so we'd say centimeters squared. Taking a look at this next circle, again, we know it's a circle. Area equals pi r squared. Looking at this 8, though, this goes from one side all the way over to the other. So this is actually my diameter. So to get my radius, I just need half of it. So half of 8 is 4 centimeters. And I need my radius for my formula. Area equals pi times 4 squared. And we'll put our answer in terms of pi. So 4 squared is 16. So we get 16 pi. And this is going to be approximately 16 times 3.14, which will give us 50.24 centimeters squared. So that's how you find area of a circle. This part, remember, is called leaving your answer in terms of pi. And then this answer is our rounded answer then. If you go ahead, flip over to page 12, so we're kind of skipping around here. We're on page 12 now, talking about the perimeter of a circle. So circles get a special formula for their perimeter since they don't have technically straight edges, because we look at a circle and we typically call them curved. So we can't add up all the different sides. So the way that we do this is we actually find perimeter of a circle called circumference. And if you look underneath the circle on your formula sheet, you will see this formula. Circumference equals 2 times pi times r. So 2 times pi times the radius. So to find the circumference here, we look at our picture. This is our radius. So circumference equals 2 pi r. Again, we can leave our answer in terms of pi. We're going to plug in for the 5. And to get it in terms of pi, we're just multiplying 2 times pi times 5. So I'm going to actually multiply the 2 and the 5 to get 10 pi, which is approximately 31.4. Perimeter, remember, is just a linear unit because you're like taking a piece of yarn. So a piece of yarn would just be measured in centimeters. So circumference, because it is a type of perimeter, is just going to have a plain linear label, so just centimeters. In example number 2, again, we see the diameter across here, which then tells me that the radius is half, so the radius would be 4 centimeters. Circumference equals 2 pi r. 2 pi times 4. 2 times 4 is 8 pi, which is going to be approximately 8 times 3.14, 25.12 centimeters. Taking a look down here, Reagan is making a cylindrical gift box for a baby shower on Saturday. The box is going to look like a picture, and the radius of the circular base, so the radius is going to be 5 inches. Everything is done except for the ribbon that goes around the outside of the box. So the ribbon is going to go around the outside. If we're looking at it from the top, it's going to make that circle. The radius is going to be 5 inches. So what length of ribbon will she need to purchase? Because we're going around the outside, we're finding the circumference here. So we're doing 2 times pi times r. And I should have replaced my r with a 5 there. So that's going to be 10 pi. Unfortunately, when I go to the fabric store or wherever I'm buying my ribbon, 10 pi isn't going to help me. So I actually do need to go ahead and multiply, which will give me 31.4. So in order to actually cover this, if I'm going to buy a length of ribbon, we could say that she needs to buy the 31.4 inches, but most likely she's going to end up buying 32 inches here. So because we would need to buy that extra hole, needs 32, that's going to help us out in the next piece because ribbon costs 9 cents per inch. So we're going to go ahead and do 9 cents times the 32 inches that we need to buy. And if we do 9 cents times 32, we get $2.88 for the ribbon. Taking a look at this next one here, we have a semicircle. So this is called a semicircle when it's half of a circle. And we can still actually find the area and we can still actually find the circumference. Semicircle is half of a circle. So when we talk about the area of a circle is pi r squared. We only have half of. Of reminds us to multiply. So we only have half of a circle with a radius of 6, or with a radius squared. And our radius here, diameter is all the way across at 6, so my radius here is only 3 centimeters. So to get the area of this semicircle, I'm doing 1/2 times pi times 3 squared. Half times 3 squared is going to give me 4.5 pi. And I'm going to go ahead and multiply those. And I'm going to get 14.13 centimeters squared. Circumference we could also find. We're only traveling half the distance of the circle. Okay, so we need half of the circumference, which is 2 pi r, plus, this is going to be a little funky here, We're also traveling this whole distance across here, so plus this part of our diameter, so plus the 6. And this circumference formula is going to kind of slightly change with each problem based on what we see. 1/2 times 2 times pi times a radius of 3 plus 6. So 1/2 times 2 is 1. 1 times 3 is 3 pi plus 6. And we're going to go ahead and approximate. So 3 times 3.14 plus 6 is going to give me 15.42 centimeters. On a test or a quiz, I am not going to ask you to find the circumference, but I just wanted to kind of demonstrate that for you. I would, so that's a no, but I would be asking you to be able to find area of a semicircle. Go ahead, pause the video, or well, the video will pause for you. I'm going to actually have you answer a question finding the area, just the area, of this particular semicircle. Remember, to find a semicircle, you're doing half of the area, so half pi r squared. So 1/2 times pi. The radius here is only 5, so times 5 squared. 5 squared is 25, times half is going to be 12.5 pi, which is approximately 39.25 centimeters squared. Two last ones, these are not in your notes packet, neither were the semicircles, I should have mentioned that. We have what's called here a quadrant of a circle, and a quadrant of a circle is really 1/4 of a circle. So you got it. If you're thinking about your area formula, instead of the 1/2 out front, we're going to have 1/4 pi r squared. And the funny thing is, here's your center going out to the outside. So this number right here is in fact my radius. So I'm going to have 1/4 times pi times 2 squared. 2 squared is 4, and 1/4 of 4 is 1 pi. So the area on this is about 3.14 millimeters squared. Go ahead and answer the question. You are going to find the area of this quadrant. Area here is going to be 1/4 times pi times r squared. Your radius is 7, so A equals 1/4 times pi times 7 squared. So 7 squared is going to be 49. So times 1/4 is going to give you 12.25 pi, which is going to be approximately 38.465 meters squared. So that wraps up your circles lesson for today, talking about area and circumference of the circles.